Hey, this is a discussion about upper and lower bounds prior to our discussion on set notation and asymptotic analysis. So oftentimes with algorithms, running times, we're concerned with which algorithm's better, and the same thing goes for functions. So in order to do that, we use upper and lower bounds, and we also use big O, which will be covered in a later video. Essentially, all an upper bound is it's saying that one equation is larger than the other equation for significantly large values of x. And all that significantly large means is that if we go out to infinity, eventually this equation will always be larger than this equation. So if this is g of x and this is f of x, then we'll say that f of x, the lower function, is bounded above by g of x. And you could also say that g of x is an upper bound of f of x. So that could become a lot more clear when we look at graphs. And we'll see here that this is a graph of x squared and this is a graph of x. And so it's pretty easy to see with these graphs that x is lower than x squared. So x squared is the upper bound of x. We can also look at other things like x squared versus x cubed. X cubed is larger, and so x cubed is an upper bound of x squared. And you can just go on and on and on comparing graphs like this. So this one is of radical x versus x, and we can see that x is on top, so x is an upper bound of radical x. And lower bound is just the opposite of upper bound. So radical x is a lower bound of x. X squared is a lower bound of x cubed because it's on the bottom. Now that's a basic graphical definition, and it works for most of the conceptual points, but just the formal definition of it is that g of x is an upper bound of f of x if g of x is larger than or equal to f of x for all values of x greater than some constant. And the value of k doesn't matter as long as some value of k works. So for this, we could use 1 because they intersect at 1, and x is always greater than radical x after 1. For this graph, any value works because x is always greater than log x. 1 again works for x versus x squared because at 1 x equals 1 and x squared equals 1, so x squared is greater than or equal to 1. And that's true for all values greater than 1 as well. And you can see that graphically. It may be easier to understand graphically, but that formal definition is there for you to take a look at and understand. And that formal definition will come in handy when we look at big O and big omega and big theta. So next we'll be covering set notation, and then we'll move on to asymptotic analysis. Thanks for watching. Stay tuned.